Today we're going to consider projectile motion. A projectile is an object that moves through the air without its own source of power. The only force acting upon it is the force of gravity. Consider this motorcyclist. He's just accelerated up the ramp and taken off, and hopefully lands safely on the other side. You can see that his path is a parabolic path, and the only force acting upon him is gravity. Gravity works downwards, just as normal. Doesn't matter where it is, the force of gravity on him will be exactly the same, and it will be equal to the mass multiplied by the acceleration due to gravity. This also means that if the force of gravity is downwards, he will be accelerating downwards with the acceleration of gravity, which we usually use on Earth as 9.8 meters per second. Now, let's have a look at velocity. He comes off the ramp with the velocity at an angle. We'll consider it as velocity v. This velocity can be split into two components. A horizontal component, which we will call Vx, and a vertical component, which we'll call Vy. As you can see, the two components will add to the total velocity. Vx stays the same throughout the whole flight because there are no forces in the horizontal direction. This is assuming that air resistance is not significant. And because there is no force in the horizontal direction, Vx remains constant in the horizontal direction. Vx is constant in the horizontal direction. Vy, the vertical velocity, changes because of the acceleration of gravity downwards. It will get less on the way up until at the top Vy equals 0. And then it will increase on the way down. This will be exactly the same as you found when you were throwing a ball vertically upwards and working the steps out. Often this is easier to see if we draw it with a set of axes. This set of axes is just showing the vertical velocity and horizontal velocity. There's no acceleration or force. As you can see, the vertical velocity changes due to the acceleration of gravity downwards the whole time. But the horizontal velocity stays the same because there are no forces in the horizontal direction. As I said before, this is assuming that air resistance is not significant. We can work out the velocities by using trigonometry. If we know the direction of the velocity and the size, so we'd need to know the length and we'd need to know the size of the angle that it's at. If we draw a simple right-angled triangle then, this one's v, the total velocity, this will be Vy, and this will be Vx. Vx then equals V cos theta, and Vy equals V sine theta. You can see this if you draw a triangle. V, Vy, Vx, and this angle being theta. Cos theta equals adjacent over hypotenuse, which is Vx over V, which when rearranged gives us this equation. Sine theta is opposite over hypotenuse, which gives us Vy over V, and will give us this equation. Now you know how to work out the two velocities. You know that the force downwards is always gravity, and that is the only force acting on it. And you know that acceleration is always downwards due to gravity at what we use as 9.8 meters per second squared. This is the end of part 1.